Welcome to clickmyproject.com. The project title is Integer Forcing and Forward Transceiver designed for MIMO multipair two-way relaying. The project abstract is we propose a new transmission scheme called Integer Forcing and Forward, that is IFF, for communications among multipair multiple antenna users. We propose the design of a mean square error, that is MSE based transceiver, including precoder and projection matrix for the relay and users. We are assuming the perfect channel state information, that is ESI. The sum of the equation MSE, that is sum equation MSE, and the maximum of the equations MSE, that is maximum equation MSE, to exploit the equations in the relay. Our proposed strategy and compare the result with the conventional amplify and forward, that is AF, and denoise and forward, that is DF, strategies for the same scenario. The project flow diagram is to measure the forward transmission using MIMO multipair two-way relaying model. Initially, we create an system model about two-way relaying model. It is to mention the number of receiver antenna and transmitter antenna. Next, we implementing the MIMO, that is multiple input and multiple output for two-way relaying. Next, we measure the channel estimation. In channel estimation, we find the mean square error, that is MSE. In this channel estimation, 4 algorithms are implemented. First one is multiple access phase equation, second one is multiple access phase sum equations, and third one is broadcast phase maximum MSE, and fourth one is broadcast phase sum MSE. Finally, we measure the maximum and sum of average users for forward transmission. Our source code file was run from the command window. In current folder shows the many files. In that, our source code file was stored in main.m, so we have to run the main.m file. The process will be going on. It is our overall process. The values are shown in the workspace, so we can easily measure the values from the workspace. The variable name also shown in the workspace, so we can easily find the minimum and maximum value of our source code. In figure 1 shows that the probability versus SNR MSE. In X label shows that the SNR, and Y label shows that the probability. The number of users transmitted from probability and SNR. In figure 2 shows that the probability of using less than 4 users. In X label shows that the SNR, and the Y label shows that the probability of using less than 4 users. When the users are transmitting from the SNR and probability. In figure 3 shows that the outage probability. In X label shows the SNR values, and Y label shows that the outage probability value. In red color line shows sum of MSE amplify and forward, and blue color line is denoise and forward, and green color line shows that the sum and maximum of MSE integer forcing and forward. In figure 4 shows that the average sum rate of the proposed scheme. In X label shows the SNR values, and Y label shows that the average sum rates. In green color line shows the sum MSE amplify and forward, and also maximum MSE amplify and forward. In blue color lines shows denoise and forward, and red color line shows that the sum and maximum of MSE integer forcing and forward. In figure 5 shows that the average sum rate of the proposed scheme. In X label shows the SNR values, and Y label shows that the average sum rate. In green color line shows that the sum MSE amplify and forward, and maximum MSE amplify and forward. In blue color line shows the denoise and forward, and red color line shows that the some MSE integer forcing and forward. In figure 6 shows the average sum rate of n antennas. In X labels shows average sum rate, and Y label shows the number of antennas on each node. In blue color line shows the maximum value of MSE, and red color lines shows the sum of MSE. So we can easily measure the n antenna receivers. In figure 7 shows the comparison of robust and non-robust MSE values. In red color line shows the sum of MSE integer forcing forward, and pink color line shows that the maximum MSE integer forcing forward, and green color line shows that the sum of MSE non-robust error power equal to 0.4 and robust error power equal to 0.4. In comparison graph, values are shown in the table, so we can easily measure the values up to 10. The project demo was completed. Thanks to watching this video.